Welcome to Investigation 1.3. This is the community pool problem. In this problem, we're going to be interpreting expressions. So we're going to be looking at some equations and understanding what the visual model would look like. So we've kind of already done this, but some equations are a little harder to understand and sort of determine from other equations. So we've been looking at just simple equations where we have our pool and we have just a basic set of tiles around it. And so we were looking at those corner tiles and we were looking at the various side length tiles and sort of understanding what is important in our equations that we needed to represent and how we could show that with some sort of authority or with some sort of ability to show it right and show that equivalence through an equation and through a drawing. So now we're going to be looking at a slightly more difficult problem. Here is a community pool. So this is like any pool that you have in some town. However, this pool has both an indoor portion right here, and it apparently has some sort of outdoor portion. So what does the area of the pool look like as an equation? So we're looking specifically at the indoor portion for this one. What does the indoor portion of this pool look like? If we have this dimension of 4x and we have it looks like we have 4x being this portion, sort of from the side of the building up to this portion of where the radius of this half circle starts, and then we have this half circle portion. So if we look at this half circle portion, what's nice is it shows us specifically that the half circle of this is x. And it also looks like our side length of this rectangle is 4x. So we need to create an equation for this part of the pool. One thing that's really important, and one thing you've already looked at when we were doing the looking for Pythagoras book, is breaking up shapes can sometimes be very, very helpful when we're looking at area. So we're going to do just that. We're going to break this up into two shapes. We'll have our rectangle portion of the pool all the way up to the wall, and then we'll have our half circle portion of the pool up to the rectangle. And so if I were to look at just this rectangle part of the pool, we have one dimension that's 4x, and if I look at this height, I can't necessarily determine how tall it is on the left side, but on the right side, I know that half of it, the radius of this half circle is x. And if I know circles, then we have essentially two radiuses make a diameter. So we have x and another x, or the height of this pool is 2x. So our rectangular portion of the pool is 4x times 2x. Now all we need to do is simplify this baby. I have 4 times 2, which I can multiply, and I get 8. And then I have x times x. 2 x's multiplied together, that is repeated multiplication or an exponent. So 8x squared is representing this rectangular portion of the pool. Now I need to look at this half circle. So first of all, the area of a circle is pi times the radius squared. But I know that I'm only going to need half of that, so I'm just going to divide this by 2 right away. I also know that my radius is x. So instead of writing r, I'm going to put an x in there. So I know my area for this is pi times x squared divided by 2. So my equation for the area of this pool is simply 8x squared plus pi times x squared divided by 2. So that is the area of the indoor portion of this pool. It's the area of the indoor. Now we're going to take this information and we're going to look at the next part of this. Because part of this investigation requires you to not just look at the equation, but also be able to interpret that and turn it into a drawing. So your part of this investigation is going to be to not just look at the indoor portion of the pool, but also sort of construct the outdoor portion of the pool. So if we had this equation, if this equation represented the pool, what part of the equation represents the outdoor portion of the pool? So we have the area is equal to x squared plus pi times x squared divided by 2 plus 8x squared plus pi times x squared divided by 4. So looking at this, we should be able to essentially take out anything that's the indoor portion of the pool. So we're going to identify those parts. We have this 8x squared that we had before, and we can see that the 8x squared is in that part of the equation. We have that in the equation. We also have pi times x squared divided by 2 as part of the equation. So we're going to take these portions out. They represent the indoor portion of the pool. And everything that's left over is the area of the outdoor portion. So we have area is equal to x squared plus pi times x squared divided by 2. And looking at this, we can probably figure out what this would look like. X squared is probably like taking, instead of the whole half circle, we have something that's just the radius in width. And then we also have something divided by 4. So that's a quarter of a half circle if I think about it, because I have pi in there, and pi represents a circle, and blah, blah, blah. So you're going to play around with actually creating the outdoor portion of this pool. So play around with this investigation. We have investigation 1.3, the community pool problem, and your job will be to do A through D of this problem. Enjoy, and I hope as always that this video helped a little bit. Thank you so much. Bye.